Okay, so graphing a linear two variable inequality. We're going to sort of do this activity kind of like we would have done it in class. It says in problem 940, you found that the points on the line are the only points that make the equation y equals negative 2x plus 3 true. But what if you want to graph the solutions for the inequality y is greater than or equal to negative 2x plus 3? How will that graph differ from the graph of y equals negative 2x plus 3? Well, what I've done here is I've got another graph of y equals negative 2x plus 3, but this time we're going to look at a few points, and we're going to see whether or not they make the inequality true. So let's say we look at 0, 0 first. We always like to take a look at 0, 0. It's always an interesting point. So if we plug in 0 for both x and y, does it make a true statement? And we would say 0 is greater than or equal to 0 plus 3. 0, is it greater than or equal to 3? No. So we would say this point does not make the inequality true. So we wouldn't graph that point. Let's pick another one like, say 2, 4. All right, so 2, 4. Let's say you had that point. So 4 is the y coordinate, 2 is the x coordinate, and you'd have 4 is greater than or equal to negative 4 plus 3. Is 4 greater than or equal to negative 1? And we would say, yes, it is. So that means this coordinate, 2, 4, is true. It works for that inequality. Let's try another one. Let's try something like way over here, like 7, 0. So if we were to substitute 0 for y, is 0 greater than or equal to negative 14 plus 3? Yes, 0 is greater than or equal to negative 11. Okay, so 1, 2, 3, 4, 5, 6, 7, 0 worked. So I'm starting to get points that are on this side of the line, and we found that 0, 0 did not work. So I'm going to try another point over here. Let's try 1, 2, 3, 4, negative 1. So if I plug in 4, negative 1, let's say negative 1, is it greater than or equal to negative 2 times 4 plus 3? Is negative 1 greater than or equal to negative 8 plus 3? And we would say, yes, it is greater than or equal to negative 5. So 1, 2, 3, 4, negative 1, that also worked. All right, let's try one way over here. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So let's try negative 1, 8. So my hypothesis here at this point is that numbers on this side of the line are working, numbers on this side of the line not working, 0, 0 being one of them that did not work. So if I try 8, is it greater than or equal to negative 2 times negative 1 plus 3? 8 greater than or equal to 2 plus 3? Yes, great. 8 is greater than or equal to 5. So negative 1, 8 also works. So what I'm finding is that points on one side of the line are working, points on the other side of the line are not working. Points on the line are still going to work as well. So this point's going to work, this point's going to work. All of these points that make up the line are also going to work. So there were some questions. If we go back to the original page, it said, now examine the solutions shown in your graph with your team. Discuss the questions below. Are there any points on the graph that you suspect are solutions but do not have a sticker? Well, do we think there's any points on here, other points, that will work but do not currently have a dot? Well, we're predicting, or we're saying we think anything up in this region, anything on this side of that line should work. So if our prediction is that the point 3, 3 should work, so we try 3, 3, it's on that side of the line. And we say, is 3 greater than or equal to negative 6 plus 3? Yes, 3 is greater than or equal to negative 3. So we predicted that there was another point. There was another point. It does work. So we would say, yes, we think there are some other points. Are there any stickers that you think may be misplaced? No, we didn't put a sticker on 0, 0 because it didn't work. So I think we've got good points. What about the points on the line? Are they solutions? Yes, the reason that they are solutions is because we've got that little equal to sign there. They make y equals negative 2x plus 3 true. And since we have that equal sign, it works. How many solutions are there? we could go on for a very, very, very long time. There are infinite or infinitely many solutions. We could keep graphing all of the ones on that side of the line. Where are all the solutions located relative to the line? Now, this is a tricky one. The actual answer is above. And I'll tell you why. They are above the line because this equation starts with y. If it's y equals, y is greater, y is less, y is greater than or equal to, y is less than or equal to, we're talking about how the points are according to the y-axis. So we're talking about points that are above points on the y-axis. So all of these points are above some point on the line. So when we want to say, oh, it's all the points on this side, we can actually shade in this side and say, we believe anything on this side of the line, and including the line, will make a true statement. So the actual answer there is above. Why are there no solutions on the other side of the line? Those would be y values less than negative 2x plus 3. Those would have y values less than negative 2x plus 3, and we only wanted y values that were greater than or equal to negative 2x plus 3. What else can you learn about solutions of linear inequalities? Think about this as you answer the questions below. Rather than placing individual sticky dots, what if an entire region of the graph were shaded like the one at the right? What inequality would correspond with this graph? Now, if you notice, this is the exact same line. It's the line of y equals negative 2x plus 3, but this time they've shaded below the line. So this one, again, notice a solid line. So the dots that are on the line would be included. Y is less than or equal to negative 2x plus 3 because we shaded points that were below the line. Heidi asks, what if I change the inequality to be y is less than negative 2x plus 3? Now notice all she changed was it's a less than instead of a less than or equal to. How would we represent that? Well, the best way to represent a less than that does not also include the points on the line is a dashed line. So the boundary line will be dashed. And what we mean by that, sort of like down the middle of the road, you're saying this is the boundary, but we're not including the numbers that are on the line. It's anything, in this case, it would be anything below the dashed line, but not including points actually on the dashed line.